Hello and welcome to this series of videos covering Python and web integration. My name is Dick van Oeveren and the goal of this series of videos is to build a web application that utilizes Python to obtain information from Aruba switches through the REST API. In this episode I will guide you through the integration and configuration of a MySQL backend. I will show you how to install the database on Ubuntu and how to access that database through the SQLAlchemy library for Python. I will also show you an example of a script that shows the content of a database table, including the ability to insert, edit or delete entries. And finally a small Python definition that obtains the status of an Aruba AOS-CX switch and shows this information on a web page. Quite a lot to cover here, so let's start. In the first video I already showed you the installation of Flask and Python, and I will use this installation to build the database integration. The first step is to get the SQL server and dependencies installed.
I will be installing MySQL release 5.7. MySQL server 5.7. Okay, provide a root password. And once that's installed, I will also be installing the libraries for MySQL. Okay, that's done. So now we are going to add some stuff to the to MySQL. So we're going to create a database and create a user, and we're going to add some data into a database table. So root -b for the password, and let's create a database. And let's create a user. Let's change to the database actually. Use Aruba. And then the next step is we're going to grant all privileges. Sorry, no, we're going to create a table first and then grant privileges. So that table contains the description, IP address, the operating system, so that will be type, username, password, and optionally a cookie. And this line grants all rights, access rights to the user Aruba. And then finally let's insert some data. Okay, let's check whether the data has been inserted. And you can see that the information is there. Cool. Next is to install the Python libraries that allow you to work with databases. For this we will use the SQLAlchemy library, which is the most common used library for Python. We also have to install the MySQL client library. And we're going to do that with the pip installer. SQLAlchemy first. And then the MySQL client. Now before we start creating the scripts, I have to explain how SQLAlchemy works. There are different methods that SQLAlchemy uses to access the database. The most common used method is the Object Relational Mapper, or ORM method. With ORM, the SQLAlchemy library uses classes to define the table structure in a database. This class can then be called with the data that is relevant for the table and then executes the statement in the class. This means that under the hood SQLAlchemy is still performing the SQL queries, but because classes are defined that actually perform these actions, this simplifies the main script calling the class. For now, I will not use the ORM method because it kind of hides what you're actually doing with the database. Instead of that, I will demonstrate the usage of plain SQL statements. ORM is planned to be covered in a later video. Good, let's start creating the scripts. The classes.py first. This script contains all the definitions that we will be calling from the init script and from the template. Let me go through the classes and then cover the stuff that is new in the classes file in this video. First thing is that I would like to store the passwords in a database as encoded strings so that they are not readable. For this I'm using a simple base64 encoding scheme. In the real world you might want better encoding mechanisms, but for demonstration purposes I will keep it simple. So for encoding we need the exclusive OR class from the Cipher library and the base64 library. If we go a little bit further down the script, you can see the encrypt and decrypt definitions. Basically what we're doing here is apply an exclusive OR function to the salt. So that's a pass key for encrypting and decrypting, and then apply that salt to the password and then encrypt that. So if you know the salt, you can decrypt the content. If you look closely to the command, you can see that the result is represented as a string in UTF format. If we would just issue the encrypt command, the returned value would be a byte representation and not a string. Therefore we have to convert it to a string so that we can store this in a database. Next is the import of the SQLAlchemy library. You can see here that the SQLAlchemy library is imported and that we are creating a session with the create_engine command. In the brackets you see the URL for connecting to the database. In this example it's MySQL, but SQLAlchemy supports various other database engines. The echo equals true means that you can see the commands being executed in the debug screen of the Flask instance. We have covered the login and logout definitions in the first video, but I have made a minor change by introducing the try and except commands. With Python, if there is an error in the script halts and execution of further commands is stalled. We don't really want this to happen if something goes wrong in the script. So for example, if a switch is not reachable or when login fails. With the try command this is covered. If there is an error in the try, the commands in the except section are executed. This allows you to do some proper error handling. Now let's check the SQL query definition. As said, we are using the simple method here to execute queries, not the object relational mapper. So it's very easy to see what is happening here. We are making a connection with the engine, execute the query, close the session, and then return the result. And that's the classes.py. Let's check out the init.py. So some of the lines have been explained in the first video, but let me focus on the new ones. In the first line, you can see that another library is loaded, and that's the request library. This is the library that handles forms in HTML. So if you post a form, the information that comes from that form can be used by Python. Further down the script, you see the root. Because we're exchanging information, the HTTP methods have to be applied. In this example, we are adding get and post, but the script is actually only performing a post. So it's just to show you that you can add both methods concurrently. And what we see here is the assignment of the request.form information to the form result variable. So the request form is the actual response from the web page, and that's the posted data from the form. If the form result contains data, that's the if statement. So if this is true, we are checking the value of the action field. And there's 3 conditions here. So if the form result action value is either submit device, submit changes, or delete, an SQL query is constructed. So let's take the submit device as an example. So you can see the query string here. And it really looks like a normal query string. The latter part of the query contains the %s string formatting definition, and in the second part of the line you can see the values that are assigned to the definition. So that is what starts here. So it's the description, IP address, type, username, and here that's going to be encrypted here with the classes.encrypt definition. And then the query is executed with classes.sql query string. And then in the last part of the root you can see that the index HTML template is called, providing the form information. So if you have the database filled with device information, you want a table in the index.html template filled with entries. This is the result that is returned from the select SQL query. That's this query here. The form result parameter is the information from the form result. That's this parameter here. This is also used in the template. For example, when you edit an entry, you would like to show the real information that is tied to this entry, like the operating system. And now for the template. Let's edit the template here. And there's quite a lot of HTML here, so let me go through the relevant stuff. In the first part, the template draws the title bar and column information. That's here. And then you can also see that there are 2 input buttons here. That's the home button, and there's another button here where you can add a new device. And you can see that the input name is action. So that's the action value then basically. In the next section, the action value is evaluated. The action value is returned from the form submittal, and then based on the value of the action you can either add, edit, or delete an entry. And in the first section we are checking if the add device button is selected. If that is the case, a form is created allowing you to enter the relevant information. So IP address, description, username, password, and operating system type. The submit button name is called action and has the submit device value. In the root definition in the init file, this value is checked, and if the submit device button is selected, the database insert takes place. The add device section is closed with the end if statement. Now for the second part. This is really the main part where all the device information is shown on the page. And it starts with a for loop here. And so let's check out the line directly after the loop statement. That's this line here. This line checks whether the action is to edit a device. It is also important to check whether the selected device ID is the same as the device ID from the query. So info.id, which is the ID from the query, is the same as the form result ID, which is the ID that is sent by the form when selecting the edit button. So if both values are true, we are editing the selected entry and generate a form. Now you can see that the form field contains information from the query. You can see that here and here, some examples. Now there is an interesting section in the form, which is the select field. That's this part here. So the select field allows you to select from a list of values. Now it would be great if the value that is stored in the database is selected when you edit the entry. Therefore we check whether the option value is the same as the stored value. And you can see one example here. So if it is the selected switch operating system is shown as selected in the option field. Submitting the edit form will trigger the update database definition in the init script. If there is no edit action, the else statement is executed, and it will show the remaining entries from the database. Next to each entry you have the option to either edit or delete the entry. So these are the two action buttons here. So both buttons have the key name action. When you click on delete, a page will ask for confirmation. So that's the onClick parameter here. And then finally the if statement is closed with an end if and an end for. Let me show you the result in the browser. So first we have to start the instance, obviously, which we do by issuing the Python command and launch the init.py. And let's start a browser. Okay, let's navigate to the web page. And so that's an overview. So on this page I can edit, add and delete an entry. So let me just add a device, for example. Select the operating system and submit. And you can see that the device is added. I can delete it, get the confirmation. I can edit, make changes. That's cool. So let me just first delete the entries that are in here so we can work with a clean slate. So just add a device 16.1.1. That would be, for example, and let's add another one. As you can see on the page, there's also a status column, but there's no information in there. It would be nice if we can see the status of the switch. In order to achieve this, we have to do three things. So first, in general, Jinja 2 templates do not allow you to run native Python scripts or call classes or definitions. However, we can make this happen by doing the following. So let me stop the instance. And so first what we have to do is we have to add a line in the init file. And let me just copy and paste that line. That's this one. And this line tells Jinja that if the check status, so that's the key here, if the check status is called, the value classes dot check status is called. So this definition is called from the Jinja template. Okay, let's save that one. And second, let's add the line in the Jinja template. Let's go down. And we have to call the definition here. Let me just copy and paste that one. So that's this one. So, and with this line we are calling the definition from the Jinja template. And then finally we have to add the definition. We put that here at the bottom. Okay. So that's the check status definition. So this is used to check the status of the switch and return the relevant information to the template. The first command in this definition is logging into the switch, and if the response code is 200, meaning that login is successful, we can obtain information from the switch through this API call. And we're using the get command. In this example, we are obtaining some information about the management interface. One of the key value pairs of this request is the host name. So that's this one. And so if the switch is reachable and the API can obtain this information, this can be displayed in the template. Once data is obtained, the application can log out from the switch. And the definition returns the response value to the template. That's one. Now let me put it to the test again, save it and run the instance. Okay, let's refresh the page. And you can see now that we have a login failure. So basically this means that the switches are either not reachable, or there's an issue with the credentials. Let me launch the switches and try it again. I've got two switches running now, core 1, core 2. You can see the IP addresses that are assigned to the management interface. So that's 172.16.1.1 and 172.16.1.2. And let's check what is happening now by refreshing the page. And you can see now that the status has changed. Core 1 is online, core 2 is online. Let me just change the password and see what's happening. You can see now that I get a login failure. Let me edit and change the password to the proper one again. And you can see that core 1 is online again. So that's all working fine. This concludes this episode of configuring Flask with a database backend and querying an Aruba OS-CX switch. Be on the watch for more videos, and as always, if you like the video, click on the like button, and feedback and suggestions are welcome. My name is Dick van Oeveren. Thanks for watching and bye for now.